for us to find the inverse Laplace transform of big F of s, which will give us the function f of t. For this example, we're asked to give f of t as an exponential function as well as a hyperbolic function. And actually in our homework system, they want f of t as an exponential function, but again we will show both. The first step is to begin with big F of s and find the inverse Laplace transform of both sides of the equation. So we'd have the inverse Laplace transform of big F of s equals the inverse Laplace transform of 1 divided by the quantity s squared minus 16. Now looking at the table of Laplace transforms, because we're given big F of s and we're trying to determine little f of t, we'll be using the table in this direction here. So let's see if we can recognize the formula we'll use to find this inverse Laplace transform. Let's focus on the denominator, which is s squared minus 16. Notice how these two have a denominator of s squared minus a squared, but here we have a numerator of s, and here we have a numerator of a, which is a constant, which means we'll use this row to determine the inverse Laplace transform involving hyperbolic sign. So we'll first find f of t using a hyperbolic function, then we'll find it using an exponential function. So on the left side, the inverse Laplace transform of big F of s is equal to f of t, so we have f of t equals. Now before we find this inverse Laplace transform, notice how, looking at our formula, our denominator is s squared minus 16, which is in the form of s squared minus a squared, where a squared equals 16 and a equals 4. So notice how here we must have a numerator of 4 in order to apply this formula. So let's write this as the inverse Laplace transform of, let's write 1 as 4 over 4, 4 divided by 4, and then we still have a denominator of the quantity s squared minus 16. And now if we want the denominator to be 4, not 4 over 4, we can factor out 1/4 and write this as f of t equals 1/4 times the inverse Laplace transform of 4 divided by the quantity s squared minus, to make it better fit this formula, let's write 16 as 4 squared. So now we can easily see a is equal to 4, which means the inverse Laplace transform is equal to hyperbolic sign 4t, which means f of t equals 1/4 hyperbolic sign 4t. So here is f of t expressed as a hyperbolic function. And now I'll show how we can express this using an exponential function. And we'll show this two ways. We'll actually use the definition of hyperbolic sign to write this as an exponential function, and then we'll also come back and perform partial fraction decomposition on big F of s, and then use this formula to find the inverse Laplace transform of big F of s. Let's first write f of t as the exponential function using the definition of hyperbolic sine x. Hyperbolic sine x equals 1/2 times the quantity e to the x minus e raised to the power of negative x. Which means you can write f of t as f of t equals 1/4 times 1/2 times the quantity. Now the input is 4t rather than x, so we'd have e raised to the power of 4t minus e raised to the power of negative 4t. Which means you can write f of t as f of t equals 1/8 e to the 4t minus 1/8 e to the negative 4t. So this would be one way to express f of t as an exponential function. Another way would be to go back and start with big F of s, where big F of s is equal to 1 divided by the quantity s squared minus 16, and perform partial fraction decomposition on 1 divided by the quantity s squared minus 16. In factored form, this would be 1 divided by the quantity s minus 4 times the quantity s plus 4. Performing partial fraction decomposition, we would have the fraction in factored form equals a divided by the linear factor of s minus 4 plus b divided by the linear factor of s plus 4. From here we'd multiply both sides of this equation by the quantity s minus 4 times the quantity s plus 4, which will give us the equation 1 equals a times the quantity s plus 4 plus b times the quantity s minus 4. And now to find the values of a and b, we'll select convenient values of s. For example, if s equals negative 4, notice how this factor would be 0. This would give us the equation 1 equals, again, this would be a times 0 plus b times negative 8. So we have 1 equals negative 8b. So b equals negative 1/8. And now to find a, let's select s equals positive 4. So if s is positive 4, this factor would be 0. So we'd have 1 equals 8a plus 0. So notice that a is equal to positive 1/8. Which means you can write big F of s as a divided by the quantity s minus 4 plus b divided by the quantity s plus 4. So we can write big F of s as, again, a is positive 1/8, so we'd have 1/8 divided by the quantity s minus 4 plus b is negative 1/8, let's write this as minus 1/8 divided by the quantity s plus 4. So now we'll take this form of big F of s and take the inverse Laplace transform of both sides of the equation. So we have the inverse Laplace transform of big F of s equals the inverse Laplace transform of 1/8 divided by the quantity s minus 4, and then we have minus the inverse Laplace transform of 1/8 divided by the quantity s plus 4. Well, the inverse Laplace transform of big F of s is f of t, which is what we're looking for, equals, let's go ahead and factor out the 1/8 and write this as 1/8 times the inverse Laplace transform of, now we have 1 divided by the quantity s minus 4. Notice how this form now fits the formula perfectly, where a equals 4. Let's factor out 1/8 here. So we have minus 1/8 times the inverse Laplace transform of, we'd have a numerator of 1. And now let's change the form of s plus 4 to s minus negative 4. Now this also fits the form perfectly, where a equals negative 4. So now we have f of t equals 1/8. This inverse Laplace transform is equal to e raised to the power of positive 4t, because a is positive 4. So we have 1/8 e to the positive 4t. And here we have minus 1/8 times, for this inverse Laplace transform, a is equal to negative 4. So we have e raised to the power of negative 4t. So we have minus 1/8 e to the negative 4t. And of course we get the same result. Again, here we have f of t expressed as an exponential function. Here we have it expressed as the same exponential function using the definition of hyperbolic sine. And then here we have f of t expressed equivalently as the hyperbolic sine function. Again, we're asked to enter the exponential function, which again will be 1/8 e to the 4t minus 1/8 e to the negative 4t. I hope you found this helpful.